Hello everyone! In this video we will continue to examine topic 5.2, the heating effect of electric currents, and in particular we will begin to discuss the processes of measuring current and potential difference. Alright, so to actually measure current in a circuit, we use a device called an ammeter, and its circuit symbol looks like this with an A in it. Please note, as tempting as it might be, ammeters measure current, not amps. Of course, these are related words, right? The reason an ammeter is called what it is because the units of the thing that it measures are amps. But when you sort of describe what's going on, you need to be very careful to say that the ammeter is measuring the current, not the amps of wherever it is. So we have this device, but there's sort of an open question: how is it wired into the circuit? And in particular, is it wired sort of in series or in parallel, right? There are a couple different ways you can connect it to an element. You know, do you connect it in series to measure the current, or do you connect it in parallel to measure the current? And the answer is that Kirchhoff's first law implies that the current anywhere in a junctionless path, so anywhere there's not a split, is the same. So to measure the current through any circuit element, you're going to wire the ammeter in series with that element. Why? Because that's going to drive the same current through the ammeter as through the resistor. And the ammeter itself has to sort of be exposed to the same current as the resistor in order to measure that current. All right? So all of these ammeters will measure the same current. They can be before the resistor or after, and that's due to the fact that Kirchhoff's first law guarantees us that the current through this ammeter is going to be the same as the current through the resistor. Same for this ammeter here, and make no mistake, same for this ammeter here. All right? Remember that in series means connected end to end. So even though these sort of look, quote unquote, like they're kind of in parallel-ish, right? You just look to see, is the end of the resistor sort of connected to the ammeter? Well, then it's going to measure the same current. And in fact, in a simple circuit like these three, the current is the same throughout that circuit. We will talk more about this a little bit later, but we are assuming right now that the ammeter itself is not going to mess with the current. And we'll talk about what that means for ammeters a little later on.